Welcome to the political economy of the environment. Today's episode is about what's called the environmental Kuznets curve, an idea that came about in the 1990s that relates the extent of environmental degradation to per capita income. The curve looks like this. It's an inverted U-shaped curve. At low levels of per capita income, pollution or environmental degradation is relatively low. As income rises, environmental degradation goes up, but then after a certain point, it comes back down again. As people get richer, environmental quality improves. And these show an inverted U for urban concentrations of particulate matter in the atmosphere and for concentrations of sulfur dioxide. And the environmental Kuznets curve hypothesis, as it's called, is that such a U-shaped relation exists in many different environmental arenas, not only air pollution, but others as well. So let's think a little bit about how does environmental degradation change as per capita income rises? What sort of effects of rising income might we see on environmental degradation, pollution, resource depletion? One effect, the simplest one, is what you might think of as the scale effect. If the amount of environmental degradation per dollar of production and consumption were a constant, more production, more consumption, a bigger scale economy would be more environmental degradation. That's the scale effect. The second is the composition effect. If the composition of economic activity shifts over time, with some sectors becoming bigger and some becoming smaller in relative terms, and the amount of environmental degradation per sector varies, then that changing composition of the economy could affect the amount of environmental degradation. And the third is a technology effect. If, as per capita income rises, technologies improve in ways that reduce environmental degradation per unit output, that could lead to declines in environmental degradation, or at least temper the degree to which it goes up as a result of the scale effect or the composition effect. So the scale effect would look something like this. The aggregate pollution output ratio is fixed. Higher output means more pollution. Pretty straightforward. It's what many people think about when they think about limits to growth. They think, bigger economy, worse environmental degradation. The composition effect is a little more complicated. It has fixed pollution output ratios, but they're fixed in sectors, and they vary across sectors of the economy. So as the relative size of sectors changes, the amount of environmental degradation, or the aggregate pollution output ratio, changes as well. Which sectors produce more pollution? For example, more sulfur dioxide emissions, one of the most important air pollutants, per dollar of output? Agriculture, industry, or services? Well, we know that in the early stages of economic growth, agriculture dominates. In the middle stages, industry dominates. And at the higher income levels, services dominate. And sulfur dioxide emissions per unit output are highest in the industrial sector. So this might be something that could contribute to the environmental Kuznets curve, to those changes in environmental degradation as incomes rise. Could the composition effect actually account for that inverted U, however? Could it lead to a downward slope in the amount of environmental degradation as incomes rise? Well, that kind of depends on what's going on not only in the country, but in its relationships with the rest of the world. If production and consumption all take place in the same country, in what economists call a closed economy model of the world, the composition effect could lead to diminishing pollution per unit output as the service sector ultimately grows in relative importance, but you'd still be producing that pollution from industry. It's just that the composition of your economy would be shifting, so industry's share wouldn't be as large as it was before. But in absolute size, you still need shoes, you still need automobiles, you still need all those industrial manufacturing operations. So the total amount of pollution wouldn't go down. You just have what's called a concave relationship. The rate at which pollution's going up would not be accelerating, it would be decelerating. However, if you could outsource your polluting activities, if you could shift manufacturing to other countries, shift pollution to other countries, and import the goods from them, then you could actually reach that turning point. You could have a situation in which the composition effect leads to a diminishing of the actual size of your industrial sector, not just its relative size, and you could get declining environmental degradation as output rises. Of course, that would mean that you can't generalize this environmental Kuznets curve to the whole world, because not everybody can outsource. There's not another planet to outsource our manufacturing activities to. And so the reach of the environmental Kuznets curve would be to those countries that are able to outsource dirty industries elsewhere. The technology effect would imply the ability to reduce pollution or environmental degradation output ratios within sectors. And if it were the case that pollution reducing technological change is correlated with income, rising income could lead to lower pollution economy-wide. Why might that happen? Why might rising incomes trigger pollution-reducing technological changes? Well, the answer given by Gene Grossman and Alan Kruger, the folks who came up with the environmental Kuznets curve for the first time in the 1990s, was that that would happen as a result of what they called an induced policy response. That governments, not only governments, potentially also corporations and others, would respond to demand for better environmental quality on the part of the population, and that the population would make that demand effective through what they termed vigilance and advocacy. People would get together and they would demand cleaner air, cleaner water, etc. And this would lead to policy responses that would drive technological change and drive the technology effect, causing that downward sloping part of the environmental Kuznets curve. And Grossman and Kruger thought, and I think they're right, that that is the main reason why you get the EKC, the environmental Kuznets curve, where you get it. But in fact, you don't get it everywhere. There are places where the environmental Kuznets curve is missing in action, so to speak. So here are the curves for municipal waste per capita and carbon dioxide emissions per capita as incomes rise. And in those cases, we see no sign of a turning point. In fact, we actually see, if anything, an acceleration as incomes go up. So in certain respects, the environmental Kuznets curve doesn't seem to be a good description of reality. It does seem to be a good description for others, like sulfur dioxide concentrations in the atmosphere. So there's a mixed set of observations we've got depending on the environmental problem we're looking at. Why is that? Well, part of the reason might have to do with what is sometimes called the pollution dispersion spectrum. At one end of the spectrum, you have what are called uniformly mixed pollutants, global pollutants, carbon dioxide emissions destabilizing the world's climate, chlorofluorocarbons, which cause the depletion of the ozone layer. These, it doesn't matter where the stuff's emitted, the effects are global. They're worldwide. They're uniformly mixed. And at the other end of the spectrum, you have non-uniformly mixed pollutants that are very localized. Air toxics, nuclear waste, things that really impact a relatively small area in some cases. Sulfur dioxide lies towards the middle of that spectrum. It's not uniformly mixed, but it's not highly concentrated in a certain location either. It can extend over pretty large areas within a country, or in some cases even across borders. So at which end of the spectrum is the environmental Kuznets curve, that inverted U, most likely? Well, I think one could make an argument that it's actually most likely in the middle of the spectrum. At this end of the spectrum, where you've got global pollutants, the incentive for governments to do anything about the pollutants is limited by the international free rider problem. What any individual government does isn't going to really solve the problem. And in the absence of an international agreement, they're not going to do much, right? At this end of the spectrum, you can concentrate those environmental harms in particular communities, and the pressure from the population to deal with the problem may not be that great, especially if the communities where you're concentrating the problem have relatively little economic and political power, right? But in the middle, you've got cases where the pollution problems or the environmental degradation problems affect a lot of people within the country. and it's within the country, it's not outside the country, so you don't have that international free rider problem, and you can't concentrate it in limited spaces. And that's where you might get the strongest induced policy response. Finally, let's think a little bit about where the name environmental Kuznets curve came from. There was an economist named Simon Kuznets in the 20th century, taught at Yale, and he came up with something called the Kuznets curve in the 1950s, analyzing the relationship between income per capita, not and environmental degradation, but income inequality. And what he found based on historical experiences in Western advanced industrialized countries was something like an inverted U-shaped relationship, whereas incomes had grown over the decades, going back to the 1700s, inequality had risen, and then finally it had reached a turning point and inequality had started to decline. And he said, you know, that pattern, that historical pattern may not generalize to all times and places. It may not be automatic. It may have something to do with something like what Grossman and Kruger called an induced policy response. People might have demanded more income equality as time went on. But that relationship he described was called the Kuznets curve. Now, if we think about that Kuznets curve between income distribution and income per capita and the environmental Kuznets curve, as it was called, because it looked the same, only now you had environmental degradation on that axis, what you might imagine is that maybe the relationship that's going on here is actually a relationship between inequality and environmental degradation. It may be that the reason environmental degradation changes over time is related to changes in income inequality over time and inequality in the distribution of power. And so another way of looking at that environmental Kuznets curve relationship of what underlies it may be that what we've got is a relationship between a more democratic distribution of wealth and power on the one hand, and the degree of environmental degradation on the other, and that relationship is an inverse relationship. Inverse meaning that as the distribution of wealth and power gets more equal, environmental degradation diminishes. And that may be what underlies a lot of that so-called environmental Kuznets curve. Thanks very much.